good day, everyone. By the way, my name is Edgar. I'm the one of the reporter presenter in Sector 5. So since I'm the one assigned to speak first, I'll take the opportunity to introduce the topic that we're going to discuss. Since I have the opportunity to speak first, obviously because I'm speaking right now, so I'll be introducing the topic that we're going to present today, guys. Disaster risk reduction and climate change adaptation. So, Philippine Institution of Volcanology and Seismology, PHIVOLCS, and Philippine Atmospheric, Geophysical, and Astronomical Service Administration, or PAGASA, are in charge. Number one, observation and monitoring networks. Number two is technology and development and application of for monitoring. Number three is modeling and simulation for improvement and monitoring of and forecasting. Number 4, hazard vulnerability and risk assessment. Number 5, warning and risk communication technology. Number 6, technology development and application for climate change, mitigation, and adaptation. Number 7, technology development and application for disaster risk and management. And number 5 is policy research. So we should go to number 1, observation and monitoring network. Development of state-of-art observation and monitoring system for weather, climate, geologic, and oceanographic process. So number 1 is weather climate observation system. So climate observation, a first definition climate observation are sourced from numerous meteorological and related observational network and system throughout the world. To describe the whole climate system, we need to collect observation of the atmosphere, ocean, and land-based system. So, yeah. Number 2 is hydrometeorological system. Is hydrometeorological system is a branch of meteorology and hydrology that study the transfer of water energy between the land surface and the lower atmosphere. Hydrologists of, often use meteorologies and data provided by meteorologists. So, number 3, ocean observation system, including storm surge waves. Basic weather observation instrument include thermometers, rain gauge, barometers, and anemometers, wind speed meters. Example of more sophisticated equipment are wind profilers, weather balloon, Doppler radar, and satellites, even with the highly technical equipment available human observation. So, number 4 is volcano, seismic, and geochemical. The ocean observation system documented in GCOS-92 is a composite system of systems made of the sustained high quality satellite measurement of the atmosphere and ocean surface in situ measurements and ocean surface and the subsurface ocean and over the ocean. The system will support global weather prediction, global and coastal ocean prediction, marine hazard warning, marine environmental monitoring, and naval application, and many other non-climate uses. So number 5 is earthquake. The detector informs the user that seismic event displaying the information related to vibration that occur on the monitoring and possibly also recording the data in mass memory. They do not provide the distance or intensity of the earthquake but merely warn the user about vibration that has occurred. So number 6 is tsunami. To detect the observed tsunamis as they move across the ocean, NOAA depends on network of seismic and sea level observation system. These networks are owned and operate by numbers and domestic and international organization including NOAA. The NOAA tsunami program runs the USA's tsunami warning system. So number 7 is landslide. So landslide detection can be done by using diverse methods like visual inspection using image, video, and processing, satellite remote sensing using statistical method, or using machine learning algorithms And landslide detection can also be based on driven approaches using wireless sensor network. So number 8 is sensor networks. Sen- Sensor network can also offer better coverage than more centralized sensing technology, utilizing node cost advantage and networking. Organization can deploy more sensor using a wireless sensor network than they could use more traditionally technology. So number 9 is space system and facilities. This decreases the overall signal to noise ratio of the system, increasing the amount of usable data. For all this reason and more, wireless sensor network offer many possibility previously unavailable with traditional sensor and technology. So that's my part.
Okay, so let's proceed to number two, technology development and application for monitoring. It is the development of instrument and data processing and analysis system, application of technologies for improved monitoring of weather, climate, geologic, and oceanographic processes. So let's discuss the seven subparts. First, hydrometeorology is the science that studies the cycle of water. It is the process of the hydrological cycle that occurs in the atmosphere, which is the evaporation, condensation, and precipitation, and in the ground, which is the rainfall, interception, infiltration, and surface runoff, and the interaction. Oceanographic instrument measures or sample various physical, chemical, and biological quantities in the water column. And number two, volcano monitoring instrument. To fully understand volcanoes behavior, monitoring should include several types of observation, which is the earthquakes, ground movement, volcanic gas, rock chemistry, water chemistry, remote satellite analysis on a continuous or near real basis. In an earthquake monitoring instrument, seismograph are instruments used to record the motion of the ground during an earthquake. In tsunamis monitoring instrument is the instrument is used to detect tsunamis was the tsunamis detection buoys. In landslide monitoring helps to prevent any mishaps and accidents. Vibrating wires, piezometers, can be used for the accurate measurement for the pore water pressure. And number three, instrument test bed facilities. It provides the realistic hardware, software, environment with which to test. It is a platform for conducting vigorous, transparent, and replicable testing of scientific theories or and computational tools. In number four, the radar data processing technologies is a widely used. It's typically civilian uses includes air traffic control and maritime surveillance, while in military uses can be found chiefly in air defense, fire control, and missile interception and guidance. In LiDAR data processing technologies, LiDAR technology enables the data capture on the field by lighting the target using the pulse laser. In remote sensing airborne spares technologies, remote sensing is the process of detecting and monitoring the physical characteristic of an area by measuring its reflected and emulated radiation at a distance. And that's all. Thank you.
Oh, hello guys. Modeling and simulation for improvement of monitoring and forecasting. Modeling simulation for improved forecasting and simulation for disaster and climate scenarios. Number 1. Numerical weather, subseasonal and seasonal climate prediction, climate change projection. Weather and climate events continue to exact a toll on society despite the tremendous advances and investment in prediction science, and operational forecasting over the past century. Weather-related hazards including early or late onsets of rainy seasons and chronic events such as drought and extended periods of extreme cold or heat, trigger and account for a great portion of disaster losses. Quantitative precipitation forecasting (QPF) using numerical weather prediction models. QPF depict the amount of liquid precipitation expected to fall in a defined period of time. In the case of snow or ice, QPF represents the amount of liquid will be measured when the precipitation is melted. Next, high impact weather forecasting and warning. An impact day's weather is not considered extreme or severe. Life-threatening weather, light rain or snow or ice during a morning, evening, or evening commute would be examples of impact weather. Number 4 is projecting future 1 degrees Celsius and 1.5 degrees Celsius Philippine climate using regional climate models and their impacts to different sectors: health, food security, water, resources, etc. Philippine authorities are predicting the climate change to up by 1.0 degrees to 1 degrees Celsius by the upcoming 2022 and so on, and they are looking at what are the potential impact of the said climate change on the other industries. Number 5, data analytics and predictive modeling for flood monitoring and management. 6, geophysical, geochemical, geodetic, and related modeling simulation for geological hazards, monitoring, and warning. 7, potential for large-scale eruptions, earthquake, tsunami, and landslide generation. To sum up all this is all about the modeling and practicing on how to improve our capabilities to monitor natural disaster, improving our means on forecasting, and to have an effective plan on how to adapt and mitigate those natural disasters because we can't avoid it. So improving the system is good for our country to lessen the possible impact of it to the other sector of the economy.
So moving on to hazards, vulnerability, and risk assessment. So what is a hazard assessment? A hazard assessment is the process used to identify, assess, and manage health risk and safety hazards in the workplace. So the purpose of a hazard assessment is to minimize the risk of illness by identifying as many hazards as possible. So one example of this is the geological hazard assessment. This is a summary of the potential hazards present at a site that may affect your project. So GHAs, or Geological Hazards Assessment, is generally conducted by the planning staff geologist. However, GHAs can be done by a consultant and submitted for review. So another example is the Hydrometeorological Hazard Assessment. So this hazard assessment can be qualitative or quantitative. Qualitative assessment meaning examination or observation-based methods for conformity that qualifies for the condition of a piece of legislation or a relevant norm. So next is the quantitative assessment. It is the mathematical, probabilistic, or stochastic based on the existing or real-time information fed as a model input. So moving on to the climate and disaster exposure database. So in order to assess and analyze the risk people face, their dwellings and places of economic activity, it is important to have a set of data that will describe their characteristics in relation to hazards and climate change. So a computerized system containing consolidated information on exposure, vulnerability, and resilience must be developed to be able to visualize the risk associated with the past, the current, and the potential catastrophes in the future. So, exposure database provides baseline information pertaining to the elements at risk. So, elements at risk refer to the population, the assets, the structure, economic activities, and environmental resources. So, last is the vulnerability, capacity, and the risk assessment. So this is a process of participating investigation designed to assess and address major risk affecting communities. It aims to determine people's vulnerability to those risks and their capacity to cope and recover from disaster.
Warning and communication of information. Development and use warning and information system and protocols, determination of stakeholders' information needs for improved warning and communication of information of impending hazardous events and impacts or appropriate preparedness and response. Warnings must reach those at risk. Clear messages containing simple, useful, and usable information are critical to enable proper preparedness and response by organizations and communities that will help safeguard lives and livelihoods. Trust is a big part of effective risk communication. If the information source cannot be trusted, those at risk may not respond proactively to the warnings, and it takes a long time to establish trust. Regional, national, and local communication systems must be pre-identified and appropriate authoritative voices established. First is warning communication, geological, hydrometeorological, climate-related hazards and impacts. Second is impact-based, risk-based modeling and forecasting. Third is Philippine Unified Meteorological Information System. Fourth is web-based and mobile phone-based warning information. Fifth is Geological Disaster Information Portal. Sixth is risk communication. Seventh is community traditional media systems. And last but not the least, communicating uncertainties of climate changes projections for DRR or CCA. Thank you for listening.
Sixth is the technology development and application for climate change, mitigation, and adaptation. This is the development and application of instruments, tools, systems, protocols to mitigate climate change by reducing greenhouse gas emissions and to adapt to climate change in all sectors, including food, water, health, environment, businesses, infrastructure, and settlement towards a climate change resilient society. So these include, number 1, reduction of greenhouse gas emissions, number 2, biofuel and forest residues, number 3, energy efficient products, non-fossil fuels, number 4, microbial biotechnology for sustainable waste management and alternative energy source. Fifth is the resource efficient and cleaner production of industries. Sixth is the advanced transport. Seventh, food, water, health, security. And eighth, the decision management tools for climate change resilient environment.
So here we have the Part 7 in Sector 5, Technology Development and Application for Disaster Risk Management. It is an assessment of people's hazards, climate change, and disaster risk perception, gaps and needs, and development and application of appropriate options for risk management, development and application of instruments, tools, protocols, and products in all phases of management, from preparedness, mitigation, response, and recovery. First, we have stakeholders' needs and disaster information gap assessment and bridging for disaster. The stakeholders are responsible for assessing what is needed before, during, and after a disaster. It is also their responsibilities to fill in those missing information in order for people to be able to know what to do in a disaster. Thus, they are also bridging the gap in order to make a difference and reduce possible risk of residential communities. Now, who are the stakeholders? So we have the media, government, NGOs, donors, community and citizens, regional cooperation, private sector, and lastly, the academia. Second is the hazard and risk perception or behavior. Hazard perception is the ability to recognize any actual or potential hazards as soon as it's possible to do so. Risk perception refers to people's subjective judgments about the likelihood of negative occurrence, such as injury, illness, diseases, and death. Risk perception is important in health and risk communication because it determines which hazards people care about and how they deal with them. We have 4 factors of risk perception. These are the cognitive factors. Examples are the gravity of events, media coverage, and risk mitigating measures. The second is we have the affective factors. These are the emotions, feelings, or mood. Third is we have the contextual factors. This, for example, is the availability of alternative information and sources. The last is that we have the individual factors. The examples are personality traits, previous experience, age, and gender. So knowing these things will help us and stakeholders be prepared and create actions. So number 3, we have the institutional or social preparedness and response. These are a set of measures undertaken by governments, organizations, communities, or individuals to better respond and cope with the immediate aftermath of a disaster, whether it be human-made or caused by natural hazards. The objective is to reduce loss of life and livelihoods. Number 4, we have the projection and impact scenarios for preparedness to respond and recover. So early warning systems and communication systems will help ensure that cities, communities, and individuals threatened by natural or other hazards can act in sufficient time and appropriately reduce injury, loss of life, and damage to property and fragile environments. Turning awareness of the natural hazards and risks faced by a community into actions will prove its capability to respond to and recover from disaster. Preparedness plans need to address not just the immediate response, but also long-term recovery and reconstruction. The National Preparedness Goal describes 5 mission areas: the prevention, protection, mitigation, response, and recovery. Number 5, interactive and dynamic platform for product and services. Via an interactive web portal, users can access, for example, specific information. Interactive platforms are targeted and personalized content that enable an immersive experience for both the external and internal communication. With the aid of high-technology devices, these platforms can help identify life-threatening hazards, give warning of them, and evacuate people from dangerous situations, maintain communication in an emergency, or provide effective support for relief workers in disaster areas. 6. Tools including software for mainstreaming DRR CCA into contingency planning and local development and planning process. So tools for mainstreaming disaster risk reduction is used by development organizations in adapting programming, project appraisal, and evaluation tools to mainstream disaster risk reduction into the development work in hazard-prone areas. The series is also of relevance to stakeholders, aims to reverse the vicious cycle of disasters and determine economic and environmental instability. Indeed, development planning helps local government units to systematically create enabling environment for sustainable development that meets people's needs. 7 is that we have the technologies and products for disaster mitigation, disaster prone, and recovery disaster stricken of communities. The role of technology in disaster can be predictable in such a way that it minimizes the hazard and helps in reduction of vulnerability. Technology has been employed to fast-track disaster relief efforts. The wide spectrum of technologies used in all 4 phases disaster management are remote sensing, geographical information system, global positioning system or the GPS, satellite navigation system, internet, email, online management database, disaster information systems and networks, robotics, etc. Application of all these technologies in this disaster management are a great help to people. 8 is we have technologies for addressing drought, example cloud seeding. A wide variety of technology solutions are available today that can quickly put the state on a path to drought resilience. So these are the technologies people use in addressing drought. We have the satellites, strip, clouds seeding drones, microdrip irrigation, often harm vertical farm, and wave-powered desalination system. 9. Climate and disaster resilient infrastructure. Infrastructure resilience is the ability to withstand adapt to changing conditions, and recover positively from shocks and stresses. To make an infrastructure resilient to climate change, we reduce urban heat island effect by planting trees and building green roofs, lower building energy demands by reducing indoor temperatures and shading building surfaces. Spend less energy managing water by reducing rainwater flows into sewer systems. Investing in disaster resilient infrastructure can help in risk reduction in loss of life and property as global warming continues to increase in the incidence as well as severity of extreme weather events. 10. Climate and disaster resilient livelihood business continuity. The MSME sector plays an important role in ensuring an inclusive socio-economic development not only in the Philippines but also at the regional level. They are committed in strengthening the resilience of business sector in the country by conducting forums, engaging stakeholders in the development of resilience roadmaps, and increasing public awareness, business continuity management concepts and strategies. Lastly, number 11, gender equality and integration in science and technology for DRR and CCA partnership. We should understand how gender relationship women's and men's lives is critical to disaster risk reduction. Because women and men have different roles, responsibilities, and access to resources influence how each will be affected by different hazards and how they will cope with and recover from disaster. So, we should increase our understanding for gender concerns and needs in risk reduction. And government should address issues and encourage to take action and bring an equal participation into disaster risk reduction legislation, policies, and programs for sustainable development to any gender. And that will be all. Thank you.
The last one is policy research, development of policies for climate mitigation and adaptation and disaster risk management. Policy research for climate change, mitigation and adaptation. Policy research for disaster risk management. Research on those fields and to have a policy to improve those sectors. Climate change is not a constant thing in this world. It keeps changing within a second. Disaster risk management research is a crucial thing to a country because it helps a country to have a good program after the disaster, what to do after, and to create a specific strategy on how to cope with it, and to be able to inform the people on what to do before, during, and after a disaster. That's all for our presentation. Thank you, and we hope you learned something from us.